Isosceles triangle today. Little digging deeper into the isosceles triangle. Because right now, here's where we're at with isosceles triangle. What do you guys know? Two sides, and that's where our knowledge ends. Okay, but I also hate to break it to you, there's also two congruent angles in an isosceles triangle. Yes, the two sides, there's always two sides, but also there's always two congruent angles. First thing I got to show you is how to locate where those congruent angles are. All right, so if you have two sides congruent, so in my first diagram, I have AB congruent to AC. The congruent angles are always across from those sides. So if you look across from one side, it's angle B. And if you look across from the other congruent side, it's angle C. And since it's isosceles, those two are congruent, B and C. All right, B and C. But I do not want you to get in the habit of saying it's always the bottom angles, because that is not true. Oh, it's just always the two bottom ones that are congruent. Baloney. Watch my new diagram here. And you don't need to copy this down. Now I'm rocking with triangle DEF. DF is congruent to EF. Where are my congruent angles now? Angle D is congruent to angle E, okay? Do not assume it's always the two bottom ones. Find the congruent sides, look across, that's where the two congruent angles are. Everybody all right? The same can be said, and I could go backwards. Let's say I know those angles are congruent. Now I can go in reverse and say, oh, across from that angle, that side must be congruent to that side. So that's what we're working with today. All right? Everybody good? Questions? Okay. Now, instead of saying, it drives me nuts saying, oh, the congruent angles, the congruent sides. Can we put a mathematical name and vocabulary to it? Yes, we can. Let's do it. And you're going to help me. So you have terms related to the isosceles triangle here. The angle between the congruent sides, or the non-congruent angle, as I like to say, because we know in my diagram, B and C are congruent, right? Because they're across from the congruent sides. So the non-congruent angle right now. Anybody, I'll let you show off if anybody knows it. The non-congruent angle in an isosceles triangle, what we refer to that as. Because I am tired of saying non-congruent angle already. Anybody? Begins with V and ends in vertex. Easy, I still got kids thinking. Anybody? Vertex. Wow, you guys really are honors, aren't you? You guys are honors, yes. The non-congruent angle in an isosceles triangle is indeed called the vertex angle. All right, let's move on. What about the two congruent sides? Again, I don't want to call it the two congruent sides anymore. Let's actually refer to them to their mathematical name. And just throwing this out there, some kids in period 1 knew. Just throwing that challenge out there. How much better are you?
Linear pairs. Corresponding units.
Anybody know what those sides are called, the congruent sides?
Congruent sides.
You have two of them.
Legs. Yes, sir. Turn me up. Turn me up.
Boy, this is going to get even better, I can tell. What about the non-congruent side, the outcast, the black sheep? Most of you could probably relate to it. Too harsh? The unequal side, anybody? Here's a hint. It may not be on the bottom every time.
The top.
Wow.
The wall, the roof. The bottom. Base.
Okay. In the high school level here, base does not equal bottom. Okay? Base is just the non-congruent side. It could be anywhere. All right? Base does not equal bottom. Oh, Finally, let's get this misery over with. The two equal angles.
Corresponding.
Angular.
Is it another one of these like legs things?
Congruent.
All right, here you go. What is the side in between the congruent angles called? We just called it the what? The side in between the two congruent angles.
Oh, the oh my God!
The side in between the two congruent angles we just called the what? Base. So we call these the base angles. Oh boy. So let's start referring to them this way instead of the congruent sides, the non-congruent angle. All right, let's see what we got now. Let's put all this to use. Okay, I have a nice looking diagram with some markings. How many isosceles triangles do you see?
One.
I now have 1 through 5 on the table.
One.
Let's find out. Somebody name one isosceles triangle for me right now. Name it, please. 17, you're up. Triangle. TRS, the big dog, is indeed isosceles. How do I know TRS is isosceles? Angle R and angle S are congruent. It's got two congruent angles. All right, there's more other than one, so sorry for the people who said one. 2. VWS, yes, VWS, because these two angles are congruent, correct. You guys that said 2, I'm sorry to break it to you. There's another one. One more isosceles triangle, 7. RUV, correct? Because RU and UV are marked congruent. Okay, so I want to apply this theorem now that if I have two congruent sides, that means I have two congruent angles. So angle R is congruent to what other angle? And I'm going to specifically ask for one that is not marked in the diagram. Don't give me it's equal to angle S. I get that. That's marked. That's given. But angle R is also congruent to what other unmarked angle in this diagram? Based on what we've already talked about, isosceles triangles. Angle R is also congruent to what other angle that's not marked right now? Thoughts? 12? Calm down. 14? U. Yes, angle U, VR. Okay, again, before we write down an official theorem we're going to use from now on. Why is it UVR? Everyone take a look. Everyone sees this triangle is isosceles. These two sides are congruent. What's across from them? Congruent angles. Okay, so what is the official theorem we're going to write now, including tomorrow in our reasons column when we do proofs? Here we go. In a triangle. Congruent. What did we just prove? Angles or sides? What did we just prove? Angles or sides? Congruent angles are across from
Each other.
no. Congruent angles are across from congruent sides. And usually I get the argument, do we have to write in a triangle? Yeah, you do, because this doesn't work for like a 4-sided figure, a 5-sided figure. It only works in a triangle. All right. Keep rolling here. RT. RT. Segment RT is also congruent to. Hopefully you give me another side in that same triangle that contains RT. RT and what other side are congruent? Here you go. You're up, 17. RT congruent to TS. Again, now we're using isosceles triangle TRS. So here we go. Why? Almost the same reason, except we're going to flip it. In a triangle, Congruent, what am I proving now?
Sides.
Sides. That's how you can tell what should come first. What did you just prove? Congruent sides are across from congruent angles. And finally, one more, VW. Segment VW. Make sure you pick a side in the same triangle. Come on. VW and what else you got for me? 3? WS. And my reason in a triangle, congruent. What did I just prove? Sides are across from, again, this is going to go into our reasons column tomorrow. Congruent angles. Okay. You can flip it over, that's fine. Please don't start those 2 algebra problems right now, because I do need your focus here for the biggest part of my spiel today. The biggest thing is when can I use this, when can I not use this, what we've talked about today. So I'm going to call this ABC, DEF, X, Y, Z. All right. What I've shown you today only applies to the same triangle, when the sides are in the same triangle. Here's what I mean. Okay, we know this from today. What 2 angles are equal? B and C. The ones across from the congruent sides. You cannot do that if the sides that are congruent are in 2 different triangles. That doesn't work. You can't tell me, oh, hey, those are congruent, so the angles opposite, F and Z, are equal to. No! No! It only works if the sides are in the same triangle. If they're in 2 different triangles, that's a no-go. Okay, that's a no-go. Absolutely not. Do you see where I'm getting at? If the congruent sides are in 2 different triangles, you cannot say the angles opposite are congruent. Those congruent sides have to be in the same triangle. We good there? Okay. You and your group right now, just like we did yesterday, but now you're going to do it with an algebra problem. First of all, your diagrams are missing a little something, something there. So can you put a 55 in the bottom left-hand corner for me? And in diagram number 2, can you mark those 2 sides congruent? Somehow they didn't come up on your version. So make sure those are there because the problems are almost impossible without those. You and your group discuss it. When you're in agreement, you know the deal. Call me over. I'll take a look. And you have plenty of time to start the assignment.